Alright everyone, so today we have a really nice new product being announced. It's not one of our products, it's, as you can see, it's an XHover product. For you guys that aren't familiar with XHover, they make very nice units out there in the market. I believe they make about four units, mainly a 300 FPV racer, a 230 millimeter FPV racer, and then now the new 180 millimeter racer. Now, this unit has been released at the time, as you know, at the time of this video. It was released, I would say, about 4 or 5 days ago. There's been a lot of interest in it. I want to thank the guys down at XHover that sent us one of these units with their own flight controller, which is an ACE32. They sent us their own ESCs, their own motors, and obviously the unit. Now, you know, everything is pretty much mainly the unit here. I'm not sure if when you purchase one from their site, if it is going to come fully built and assembled like this. This is how we received it, so obviously this is how I'm going to do the video. So, you know, if you receive a unit and maybe it's not built, you know, I'm sure, you know, I'm not too sure how they're shipping them out, but like I said, all I know is this is how we received it here. Now, these units, we are going to be carrying them on our website as well. We're going to have obviously the frames, ESCs, their motor combo. So for you guys out there that, you know, maybe want a built unit, as you guys know, Drone Pros has really been known to build very, very good units. And not only that, our wiring is very clean and our programming on our units is absolutely just right on. For anybody, you know, that's purchased our units, you know that our flight controllers, when we say tuned, we mean 100% tuned. You don't have to go and tinker with the PIDs or none of that. So, getting on with the video, as you guys can see, it is a 180 millimeter unit from motor to motor. Now, this unit can carry full FPV equipment, you know, video transmitter. It can carry FPV camera up in the front. It can carry, believe it or not, it can carry a GoPro or a Mobius camera. I have seen this thing fly with a GoPro, and trust me guys, it has absolutely tons of power. We're gonna have more videos coming up here, you know, after this review. Those videos are going to be showing it with the GoPro mainly. We might get a few videos with the Mobius, but yeah, this unit running on the 1306 3100 XHover motors are absolutely crazy. Just right out of the box, this thing has a lot of power. Now, this unit is typically offered, especially I know XHover, they offer it as a kit form. I believe they're going to have some pre-built models as well. Like I said, don't quote me on that. But I know us here at Drone Pros, we're going to offer a kit form. So you can purchase it like this, everything in pieces, and then we're going to have an almost ready to fly. And we're also going to have ready to fly with FPV on there. So we're going to offer quite a few different combos. I know there's a lot of guys out there that don't like spending the time to build, don't like soldering, don't like doing any of that. But luckily, on this video series I'm be doing today here on the XHover or MXP 180, I'm going to do an actual full build video. So you guys are going to see here through this video episode, we're going to do a full build video. We're going to show you how we solder stuff, how we wire stuff, and you know, for you guys that do want to go ahead and jump on it, you know, you're more than welcome to buy a unit like this in kit form and go ahead and build. Like I said, we are going to do a full build video on this unit. So what we're going to do now is open some stuff and get back to you guys. Alright everyone, so we have here pretty much the main electronics, obviously excluding the FPV. But these are going to be the three main electronics that are going to go in this unit. We're going to start off with the 12 amp ESCs. Now these are XHover ESCs I have here. They are 12 amp. Another nice thing is they are running BL Heli software, and on top of that you can also run one shot when you're running the ACE32. For you guys that probably don't know what I'm talking about, don't worry, I'll probably make a whole new different video explaining what that is for these two guys. But like I said, that will be a completely different video. But yeah, for you guys out there that are aware, this ESC here is running BL Heli, and it is able to run one shot with an ACE32, so that's not a problem. Now, the motor we have here is a 1306 3100 kV. Let me here bring it up to the camera. But you can see it's a 1306 3100. And then here I'll bring up the ESC so you guys get a little bit closer look. It's a 12 amp ESC. It's a, you know, they're racing series, so it's a really nice ESC. And then the flight controller is right here. So you can see it comes with the whole pinout. Here, let me show those here quickly in the video. So, you know, you are going to need to solder them. Whether you solder the pin or whether you solder the wire, you know, that's completely up to you. But yeah, guys, these are the main electronics being used. You can see this 1306. It's a very small motor, you know, compared to like the 2204s, which are used in the 250 millimeter racers or bigger. But yeah, these are pretty much the simple electronics we're going to be using. So what we're going to do now is obviously we're going to take the unit apart because it did come assembled. So to build it, we're going to have to kind of take it apart. A really nice thing I like about the 180 is the parts count is very low. So to work on it, you're going to see here as we're working on the unit, you're going to see how easy it is to take apart, and we're going to pretty much get on with the build. Alright guys, so right now the way I'm going to start pretty much building this unit, we're kind of going to start on the bottom end, installing the ESCs. Once that's done, we'll install the motors, and then we'll start pretty much wiring it up, making it look nice and neat. Once that's complete, the motors and the ESCs, we're going to move our way up to the flight controller deck, which is going to be here. And once we're at the flight controller deck, we can worry about the receiver, the video transmitter, and of course the FPV camera. And after that, we're pretty much going to be complete. So a tool we like using here, obviously we build quite a bit of units, so using a typical Allen hex wrench isn't ideal for our application. But of course, if all you have laying around the house are some Allen wrenches, some hex wrenches, that's perfectly fine to use. Here we're going to be using a little Ryobi drill. This thing works great. The tools, really the only tools you're going to need on this unit are a 2mm Allen for the whole frame, and then you're going to need 1.5 for the motors, and that's really it. You don't need absolutely anything else. So really the only tools you need are two tools. It's a 2.0mm Allen and then a 1.5mm Allen. So what I'm going to do now, I'm going to leave the video here rolling. I don't know if I'll fast forward it a little bit later in the editing, but I'm going to leave the video rolling so you guys can get an idea of how I take the unit apart. Kind of to give you a rundown of how I'm going to do this. I want to take off the top plate first, completely, these two top plates. The way I'm going to do that, I'm going to take off the screw down here on the bottom, take off that screw on the bottom, this one on the bottom, this one on the bottom, and this whole deck's going to come off. After that, we're going to take off the PDB board on the bottom here, and then we're going to pretty much get going after that. So let's start. Alright guys, so we have here pretty much, you guys saw it literally took only probably a minute and a half to undo the two top plates. You know, remove the screw down here, remove the screw in the front, in the rear, and pretty much this whole set came off. So now we got here the mainframe. It is a unibody. I wouldn't be too worried about this unibody. I know a few guys out there that know about unibody designs. They're good and bad. They're good because obviously it's just one body. It's very simple to you know, to assemble and so on, maintain. The bad thing about unibodies is, if not done right, the unit, when you crash and you break an arm, you don't replace the arm. You replace the whole frame, or the whole piece of the frame that you damage. Now, that's not a big deal, you may be saying, but when you have motors, when you have ESCs, when you have flight control, video transmitter, FPV camera, all attached to that unibody, it starts becoming quite of a headache to do. But for the MXP 180, I would not be worried whatsoever. Reason for that, they're very good at the designs they do. I've you know, been with those guys. I know they absolutely know what they're doing. So this frame, I mean, it really just has no flex for a 180. I've seen this thing crash. I've seen it fly. I've seen it being crashed really hard without an issue. So that pretty much covers that. Now that we got the top two plates removed, we have obviously just two plates left. We have the main plate, and then we have the distribution plate. Now, I didn't quite talk about the distribution plate, but this unit does come with the distro board. Now the distro board also has LEDs here, which is a really nice, I think it's blue and red in the rear, or it's blue and red in front. I'm not sure, I haven't lit it up to see, but I know it is blue and red for sure. But it does come with 3 LEDs, both front and rear, and you have your solder tabs, not only your ESC solder tabs, but you have some auxiliary solder tabs and main power solder tabs back here in the rear. So what I'm going to do now is remove that, and the way I'm going to do that, I'm going to remove this 4 screws here, and then you're going to see pretty much the whole distribution board come off. So let's get to that. Alright, so there you guys go. You pretty much see the whole unit broken down. You have your 2 top plate. I guess you can call this your GoPro plate, and then this your top plate. But anyways, you have 2 plates here. You have your main frame here. Like I said, it is a unibody frame. It's very thick. I would not be worried about breaking it whatsoever. And then lastly, you have your distribution board. Now, I briefly talked about the distribution board. I want to show you guys a closer look of it. So here you can see on the distro board, let's see if I can. Alright, so you can see you have your auxiliary power here, you have your ESC main tabs here, and then you have your main battery tab here on the bottom, and then you have more auxiliary tabs here. You guys can see a little closer look at that, see how that looks. And the LEDs are here and here. Alright, so now we have pretty much the 4 ESCs taken out of their packaging. We have them here, and pretty much the way we're going to do it, the way I'm going to wire this up, is the idea is you want to fit all 4. Make sure you have your distribution board the right way. You don't want to do it like this and then later figure out you did it the wrong way. But anyways, make sure you know your ESC tabs are facing towards you. And in theory, what we're going to do, we're going to hook these up, the power leads towards the center here, which the center is here, and we're going to put them like this. So one's going to go there, one's going to go there. For this side, remember, power leads towards the center. This one's going to go here, and this one's going to go here. And now what we're going to do, we're going to cut down the main power leads just a little bit so we don't have excess wires hanging everywhere. I was going to cut down the servo leads and recrimp it. We have a full crimping tool. I can obviously shorten these to really whatever length I want. But for, you know, the video's sake, I don't want people to see this video and say, wow, that's really cool, but I don't think I can do that. So, you know, I really want people to see this video and say, well, I would have liked him to see how he would have wired the servo leads and so on. So what I'm going to do, I'm going to leave those a length. I am going to add a little bit of mesh to the motor wires. You'll see that later when we get to the motor wires. But yeah, in theory, that's pretty much what's going to happen. I'm going to show you guys how we solder power leads onto power distribution board, just to get an idea. I'm only going to show one just for video's sake. I don't want, you know, a super long video. Obviously the same step is going to be for the rest of these 3, so like I said, I'm only going to be showing one for this video. So let me get the soldering iron ready and bring you guys back when that's warmed up. Alright guys, so before I actually start soldering, I want to cover a very important thing here, and that's going to be the whole soldering station I use, the whole resin I use, and pretty much everything. So you guys have no idea of how many emails we get of people always saying how hard it is to solder. They absolutely hate it. Probably if you're watching this video, you're probably one of those people that absolutely hates soldering, and I don't blame you. You know, just like anything else, if you're using the wrong tool for the wrong, you know, sometimes even for the right job, but just the wrong tool, you know, you're going to have a lot of problems. I know a lot of guys out there that as a soldering, pretty much as a solderer, what they use, they'll go to Home Depot, they'll go to a hardware store, I don't know, sometimes Walmart has it, and they'll buy a little 40-watt solder. And that's pretty much not, I mean, I guess it'll cut it if you're doing some really small gauge stuff, but really at the end of the day, it's going to give you a really bad experience. You know, most of the stuff we deal with is, I know here we deal with 22 gauge, all the way up to 8 gauge is typically what we work with. Now, you know, the 40 watt will work. It'll get the job done if you're doing some small gauge stuff. But as you get bigger, you need more heat. Now, I've even tried the 60 watt, little cheap ones. They're about 15 bucks they sell. And pretty much the same story. I don't blame you guys for having that horrible experience with soldering. It's really what I recommend. There's a few companies out there. There's an RC company, I forget the name of them. I forget the name of it, but I think A-Main Hobbies carries their solder. It's about 70-80 bucks. But what I have here, I have the Hakko FX888. They have a newer model of this. I think is around the same money. I bought this on Amazon for about 70 bucks. So yes, you're gonna spend a little bit more money, but I've had this here for, I think we're going to about 4 to 5 years without any issues whatsoever. My experiences have been great with this, and like I tell people, 90% of your experience for soldering is your soldering tool you're actually using. The next 10% really falls into the solder you're actually using. This is a rosin core here, so it's 6040. This is a very well-known brand. It's a Kester brand. This is pretty expensive here. I think this was about a pound of solder here. I paid about 40-50 bucks, but this isn't really that important as long as you have some flux here near me, because this already has flux inside of it. But this is not too important. Like I said, this is only about 10%. If you don't get a good brand of this, make sure you get some flux and just add a little bit of excess flux, because pretty much what the flux is going to do, it's going to let this stuff drain as if it were water. So it just, when it gets on the tab, it kind of just disperses really good. But out of most of the jobs I see, soldering jobs that I see people doing, I always see what I call peanuts. And what I call peanuts and what I describe them as is they look like globs of just peanuts. It doesn't look like really the solder kind of flowed really nicely. It doesn't look, when you solder and you're done and it cools down, it should look, I don't know, what's a perfect example? It should, I don't know if you guys have used the hot glue gun, but you'll see the hot glue, it'll start off as kind of like a little peanut, and then it'll kind of just disperse and get nice and flat and smooth. That is what your solder job should look like. It should be shiny. If it's pretty shiny when you're done, it means you're using a good solder here. But like I said, the soldering tool we use here is a Hakko 888. For this type of job, I'll probably put it about 800 degrees Fahrenheit, and let me start it up. A nice thing about having a really good actually soldering station is it only takes probably about 10 minutes to heat up. So you're going to see here the little light, it's going to start flashing as soon as it's reached its heat, and typically it takes about 10 minutes. Sorry, not 10 minutes, 10 seconds. When it was brand new, it took about 10 seconds. Now it's a little bit old. I've dropped it a lot of times, so it'll probably take anywhere from about 15 to 20 seconds. But it'll reach its temperature pretty quick. Another nice thing to have, there you go, it already reached. Another nice thing to have is a sponge with some water. That's always good. And then most importantly is a little copper, what is this, like a little copper sponge, I guess you can call it. Those are really good for cleaning off any excess flux. Or if you see this tip, let me focus it. If you see this tip, it kind of looks pretty nasty right now. You can see. So what I'm going to do here, not really doing anything to it, I'm just going to bring it on in here. And you can already see it's not even focused yet, but look at how much shinier that already looks. Now, water wouldn't have done that. It just would have kind of removed any excess flux on there. And then to really prep this, what I would do is just throw on a little bit more solder there, and this is pretty much ready to go. So what I'm going to do right now, I'm going to set up the camera a little bit better. I'm going to zoom in here on this distro board so you can get a little bit better idea. The only reason I have this cardboard here is I don't want to damage my magnetic really nice work mat I have here, so that's why I have this cardboard. So let me set up the camera and give you guys a little closer look. So here we have our distro board, we have our solder. Let me put this on this side. I'm right-handed, so I'll hold the tool with my right hand, and then I'll just pull the solder with my left hand. So what we're going to be doing right now, we got the heat up to about 850 degrees on our soldering station, and pretty much we want to tin all these little tabs. And by not all of them, I'm not going to tin all of them. I'm not going to tin the auxiliary tabs, but I'm going to tin the ESC tabs as well as the main power tabs. And pretty much what you're doing by tinning, you're just prepping it. You're making sure by the time you add your wire for your ESC, it'll pretty much flow a lot nicer. You'll be able to see that later in the video. But pretty much tinning it, let me clean my solder here, my tip. So what we're going to do here, we're going to add a little bit, just a tad bit. You can see it kind of just, as soon as it touches, it melts. That's how you know you got the right heat for this. Too much heat for this distro board. I know this soldering station won't get as hot to damage this, so I wouldn't be worried. I can turn it all the way up and it'll work just as good. So we got the proper heat here. And what I like to do, I like to, with the solder, I like to kind of touch the tab and then bring the, here, let me get that, bring the iron in. And you're going to see here, I'm touching the tab and just making it flow in. You can see there. Once I have a nice little mountain, I like to call it, I kind of let off. And I come over here. Same thing. Let me pull more solder here. Same thing here. Here. So, I don't know if you guys saw there, but that was in 100% real time. You saw how quick I did it. You saw how effortlessly I did it. I'm sure a lot of you guys out there watching this video are like, wow, that actually seems pretty easy. So like I said, 90% guys is the actual tool you're using, the iron here. And then about 10% of that has to do with the actual solder here. I'll bring the board here up a little bit closely so you can see kind of what I'm talking about. So you can see here's the ESC a little bit closer. You can see those little mountains I'm talking. You can kind of see it on this side. You know, they look really nice. They're nicely formed. You know, look really nice. This is always what we look for when we solder. And I don't know if you can see, it looks like it has a liquid there. That's the flux that's in this solder here. So that flux makes it flow a lot nicer. I really almost never use flux. Once in a while I'll have to use it, but almost never have to use. So what we're going to do now is we're going to get the ESC. On the ESC, as I mentioned earlier, we do want to cut these down just so, you know, I don't like having any excess wire on there if you really don't need it. But before we do that, we're going to use some double-sided tape here, and we're going to get that mounted. And then as soon as that's done, I'll come back to you guys and show you how we solder this pretty much onto the distro board here. Alright guys, so we got the ESC mounted on there already. You can see the tape we used here is this 3M double-sided tape. This we like to buy at Home Depot in bulk. There's also online you can buy it, but like I said, we buy it in bulk. You can buy it in a pretty small pack. You don't need to buy it this big. Here you can see we have, this is kind of how the big, when you buy it in bulk, it's kind of how it comes in. Obviously we've used this one quite a bit. This is just a backup for when we run out. But anyways, this is the tape we use to hold the ESC down. This is the tape we use on, if you purchase any of our units, typically they have this tape holding a lot of stuff down, such as the ESC. So we got that done. One thing I want to mention as well, when you are mounting the ESC, you want to mount it, you know, kind of far back, not too far back, so you don't cover the auxiliary tabs here. And also what we used here as a little spacer, we use this post kind of, we don't want to block that hole either right there, because if you put this ESC too far that way, you won't be able to squeeze this post up against it. So we actually installed this post temporarily, and then we kind of found the location of the ESC, and then we kind of mounted it down in. So what we're going to do now, obviously you see these leads, we really don't need that much. We're going to cut these down, and then we're going to pretty much solder them to these tabs on that side right there. So what I'm going to do right now, I'm going to cut the leads. I'm going to tin them, because once they come pre-tinned. You can see here they've been pre-tinned by the factory here. I believe, I don't know if XHover or whoever, but someone pre-tinned this here. So when we cut that, they're not going to be pre-tinned anymore. So we're going to have to tin them once more, so that when you put them up to the tabs, they mate really nice, and you'll kind of see what I mean by that. But I'm going to cut those out. I'm going to get them tinned and then come back to you. So we got the wires cut to the proper length we felt was adequate for our distro and ESC here. Like I said, you can leave them a little bit longer if you want, a little bit shorter, but we felt this length is perfect for us. So what we're going to do now, we got our soldering station up and ready. Got our solder here. We're going to tin them. Now tinning them is pretty much the same as doing the tabs down here. You kind of touch with your solder, you touch the wire and just kind of feed into it as it melts. You can see there. And I'll give you guys a little closer look of what we like it to look like before we introduce it to the tab. So let me do that one. Okay, so let me give you guys a closer look of how that should look like. Alright, so you can see here a closer look of how they look. They kind of have a little roundness to them, which means we put a little bit of excess solder. So as soon as we put them up to here, they mate really nicely and they join really, really good. Now we're going to pretty much mate the positive and the negative to the proper tab. Be sure, guys, you don't know how many people we've gotten that work with power distribution boards and they accidentally put a red to a black and a black to a red. And you can imagine what happens when you hook up power to that. Obviously, you're going to fry that ESC, and hopefully that doesn't take anything else out with it. So be sure, guys, to double, triple, quadruple check your work. Be sure you're soldering to the right tab. We like to check that, you know, numerous times. I mean, we probably quadruple check it just to make sure, you know, we accidentally didn't solder it right. So the way we're going to do that, the red is on that side. The reds are on the outer. So we're going to get a red wire and kind of put it right over the tab. It's a little bit hard to see. I'll try and zoom in later so you get an idea of how it came out. But we got the red done, and then here the black. And it's very simple, guys. All we're really doing, as soon as we introduce the heat, they just melt right together, and that's pretty much it. So let me, you guys saw it literally took me, I mean, I don't know, I didn't count exactly, probably 10-15 seconds to solder that up. What I'm going to do now, I'm going to bring it a little bit closer to the camera and show you exactly what we look for. Okay, so here's the ESC. You can see kind of what we look for. We have a nice shininess to it. We have a nice round curve to it. And, you know, as soon as it looks like that, that's good enough. That's, you know, that's a really clean job. If anybody at the field saw this wiring job, they're going to be telling you, wow, that's a really nice job you did there. And as you guys saw, it literally only took a few seconds to solder this. If you tin everything beforehand, and like I said, guys, 90% of your thing is the station you're using. We got the Hacko one, as I showed earlier. But as long as you do that, you're going to have a great experience. So what I'm going to do now is set this down, get this, get all three of the other ESCs mounted, and then we're going to come back to you. What we're going to be doing is exactly what we just demonstrated. So you're not going to be missing anything. I'm just going to do it off the camera so the video isn't super long. Before we do that, we actually wanted to give you a tip before you continue. We got two of them mounted on here already. You can see, haven't started them yet, but got it mounted. I don't know if you remember, but earlier I mentioned you want to put on these posts. You can put two on one side when you're done, move to the next side, or just take off all four and mount all four. But I highly recommend you guys mount these posts on before you're putting on the ESCs. Reason for that is you want to make sure your spacing is right for the ESCs. You don't want your ESC to go too far that way and then later you have to scoot it back this way because obviously the post needs to clear. So I'm going to really recommend you guys put those posts on. You can do it before you start doing any of this, or you know, you can not put them on and just do one by one and just make sure you have enough clearing with the post. But the way we're going to do it, we're going to put on all four of them and just then mount the ESCs from there, because then that'll obviously tell us if we're blocking the hole for the post or if we're not blocking the hole for the post, and that'll pretty much remove any issues later when you're all trying to get the post on and you're going to see you have to scoot everything over. It just makes it a lot easier to do it now because pretty much it's all here and all undone and easy to work on. So we have here all the ESCs, all four ESCs mounted on to this power distribution board. You guys can see here. One thing I want to mention also, when you can do it when you're done or as you're doing it, we like to pull up these ESC wires right through the middle of the two power leads. So we just pull them up. We don't have the power. Let's say this is a servo wire, that we don't have the power lead kind of go over it like this. We just kind of make sure when we're wiring it that the power lead, the two power leads, it comes up right through the middle like that. So they're not like going like that or like that. So once again, this is your servo wire here, and these are your positive and negative power lead. When we're wiring it up, we make sure it just comes up right above it like that. But yeah, guys, that's pretty much it here. I'll give you guys here a closer look here of how it looks, but you want your motor wires coming out through the outside, and your power lead wires and your servo wires coming right up to the middle here. So let me bring it here so you guys can get a closer look. Power leads here, you can kind of see how they're all pulled up right through the middle, and then you can see our soldering tabs there. See, very clean look, very shiny. That's what you're looking for. You know, if someone saw us at the field, they're gonna say, wow, you know, where did you learn to solder? And like I said, we mounted the post here on the rear so we can get our spacing right. But that's pretty much it. Try not to mount your ESC too far this way, because when you crash, this is the bottom plate. Last thing you want is a branch nicking right here and damaging your ESC. So make sure you leave a little bit of clearance like we did here. You can see on both sides. So when you do crash, this in theory, when we're done, it's going to be like that. And this one's going to be like that. So, you know, when you crash, it leaves you a little bit of safety room here. So when you hit, you know, not much is going to get damaged there. So that's pretty much it. What we're going to do now is move on to mounting the motors on the frame. And then once we mount the motors on the frame, we can go by introducing the bottom deck onto the frame and then continue our way up to doing the flight controller. So we've got all our motors here. We got obviously 4 motors right here. Also be sure when you, get your motors, be sure you don't throw away the little baggie, because in there you have a total of 1, 2, 3, 4, 5, 6 screws. You're going to have 4 baggies. Each of the bags are going to have 6 screws, and those are going to be what hold your motor down. Before we begin here on putting the motors on the main frame, I want to show you guys a little tip, at least, or not a tip, but something we like to add to our units. Obviously, if you do want to purchase a unit from us that's fully built from us, this can be an option we can do on your unit, you know, without an issue. Or maybe if you want to purchase a unit, you know, as a kit form, and maybe you just want us to do it to the motors, we can do that for you. But what we've done here is, obviously you see here 3 of the stock XHover 1306 motors we got here, and then here we just added our own little touch. The only difference is we added mesh here, and obviously heat shrink on either side to seal the mesh so it doesn't open up and break up, you know, when you're flying or whatever. If you've ever worked with mesh, you know exactly what I mean by that. We also like to burn the ends on the mesh. The reason we burn the ends is, again, so your mesh, it's a lot of small little strands. If you don't burn it together, they'll all open up and flare out and look really nasty. And, you know, you spend a lot of time to make it look really great, and at the end it's going to look okay, I guess. But yeah, you can see it adds a really nice touch. The yellow, especially the yellow with the carbon fiber, looks really nice. But I'll bring it here closer to the camera so you can get a closer look of how it looks. So pretty much we add the mesh here, and then heat shrink on either side, and really gives it a clean look. Not only does it give it a clean look, we ourselves do a lot of FPV flying. So when you're flying, especially when you're going through trees, or a tree happens to pop out in front of you, as we all know it always does. You know, there was never a tree when we go to a field and all of a sudden a tree will just pop out in front of us. If ever that does happen, since these wires are running through the bottom of the arm, you know, a branch could very well pick at it, maybe disconnect it, maybe pull it, and worst of all, maybe even cut a lead, and you know, that won't be too good. So the mesh really protects it. We've crashed a lot of our units with mesh. We've had customers that we install mesh on their units, and they always get back to say, not only do people compliment them at the field that it looks great, but you know, they get back to saying, wow, we really saved them a lot of motors. So that's a little touch we use. The mesh you can see here, this is what we use. You can see here the expansion. It's not too much, but more than enough. This is perfect for like 2204s and these 1306s. So what I'm going to do right now, I'm going to repeat this step kind of off camera for all the rest of the motors, and then we'll go ahead on mounting them and pretty much take it on from there. All the motors done and meshed up, you can see here. You can see really how nice it looks. Wait till we mount it on the unit. You're going to see it looks really clean. So what we're going to be doing now, we're going to mount one motor on camera, just like we did with the ESCs, mount one on camera, and the rest we'll do off camera. Let me get a few out of the way. In theory, what we're going to be doing, we're going to be passing all these leads and the mesh right through this hole. Once that's done, we're going to screw on. Remember the screws I mentioned earlier. Should be 1, 2, 3, 4. You get a total of 6 screws, so I guess they give you 2 extra. They're all the same length. One thing I like to recommend to everyone, every time you have a motor that's going onto a frame, I mean, you know, I always recommend to do this, but always check the length of the screw. Not in this one, they're actually perfect. So XHover really did their job making sure of that, but I always like to put the screw in the frame and then making sure, you know, I have coming out about, you know, 1.5, 2 millimeter of threads. That'll ensure that we have more than enough threads going in here, because last thing you want, not in this case, but last thing you want is a screw that, you know, has a length of 8 millimeters and you go up into the windings and you mess up the motor. Like I said, you don't have to worry about it on this kit. That's just a nice advice I like to give to you guys for, you know, if you're mounting maybe your own set of motors on this unit. But like I said, these 1306 XHover motors are perfect. The screws are the perfect length. So let me get all the tools out I need to do this, and then we're going to show you guys on camera how that goes. On, we have a 1.5 millimeter Allen. We have the driver that goes with that Allen, and then we have blue Loctite. Now, I know a lot of people out there build quads, multi-rotors without Loctite. Back in the day, I used to fly helicopters, as well as a few guys here at the shop. We used to fly helicopters, but you know, flying helicopters, flying those big machines at as much power as they have, we really learned quickly that, you know, on those machines, you must, anything that's metal to metal, you must always use Loctite. I like to pass that theory on to these units. Anything metal to metal contact, Loctite is going to be the best. Obviously, we don't always balance our props in these, so you know for sure there's very little vibration. But it's not vibration to affect the flight controller, but it can be enough vibration, enough resonance to, you know, over time loosen these motor screws. And last thing you want is having a crash just because you didn't take an extra 2 minutes of your time to add Loctite to the screws. So what we're going to do now is add Loctite to these screws. Got here our Allen driver. Another thing I want to mention to you guys, for these screws, these are 1.5 millimeter. I really don't recommend using a drill bit driver. A manual driver is a lot better. Why? Because they're a lot smaller screws. The threads they're a little bit easier to strip. I'm not saying you're gonna strip this, but I'm just saying with the tool, a driver like we were using before, it's pretty easy to strip them if you're not careful. Obviously, if you set the torque properly, that won't be an issue. So we're going to start first by feeding the motor wires in the holes here. If you did the wire mesh, one thing you're going to have to, or you're going to notice immediately, is the wire is really stiff. I mean, if you really wanted to, you can get it to go down, but it's really, really stiff. So to relieve the stress on the motor, what we're going to do, we're going to get a heat gun right now. We're going to heat up this heat shrink here, and as soon as we heat it up, you're going to see how it's going to come down, and it's going to be able to be mounted a lot easier. So we're going to do that off camera because we have that at our heat guns at our other station. We'll come back as soon as we have that done. We've already heated up the heat shrink. You can see it came down a lot easier. Now it's just pretty much ready to be mounted. So to start off, what we're going to do, we're going to get our screw. Be sure, any Loctite you're using, be sure to shake the bottle for probably a minute, just to get all the Loctite ready to go. You really don't need a lot of Loctite, guys. It really only takes like a small little drop. Here, let me try and focus it. It's really tiny. Now there you go. But yeah, you can see, guys, it takes a really small drop of Loctite. It doesn't take very much to get it to bind here up to the motor. So what we're going to do, turn the unit over, kind of align the hole as best you can. You're going to put it right there. You don't want to tighten it. You just want to kind of get it snug up. A little bit more Loctite. Then you might have to slide the motor over a little bit to get it to go. There we go. Once again, guys, remember, don't put the screws tight. Leave them somewhat loose. Then get this guy. You might notice you may have to wiggle the motor a little bit to get the hold line, and that's the reason we tell you guys not to tighten it, so you have that slop to work with. There we go. Okay, now we got them all in there. They're nice and snug. So what I like to do here is look down the center of the motor here and try to get that shaft pretty close as center as possible in the carbon cutout you see there. So I'm gonna move it just a tad bit. Okay, there we go. Pretty happy with that. tighten that up. Tighten this guy up. Not too tight yet, just kind of getting a little bit more snugged up. That's pretty good. And then here we start getting them a little bit tighter, working in an X. Okay, then this guy, this will be the final. There we go. There we go. And there we go. Now I want you guys to remember that you are dealing with a 1.5 millimeter screw. So be very careful with it. It doesn't take a lot of torque to tighten them, especially with the Loctite. The Loctite's going to make sure that it seals it, it gets it up together really good, and it doesn't back out with any vibration or resonance. Now another thing we also did off camera is all these screws, anytime you're dealing with metal to metal screws, you don't have to do it. It depends on the Loctite you're using, but typically if you have a little bit of rubbing alcohol, put it on a little towel, then you put your screw on the driver like this, and then what you would do, you'd grab the towel that has alcohol and you'd kind of loosen and tighten. And what that's going to do, you can see, I don't know if you can see that there, but you can see the residue that was on that screw. A lot of that could be oil, and typically the cleaner the screw is and the post is, the better bonding you're going to have with Loctite. But like I said, you don't always have to do it. A lot depends on the Loctite you're using. Some of them will still adhere if there's a little bit of oil. So just be sure. The one we use here is Team Associated thread lock that can be found on quite a few hobby shops. So that's what we use, and it works for us. So what I'm going to do off camera now, I'm going to get all of the other 3 motors mounted in the same exact process, and then we'll show you guys how it looks done. When you're all done, don't be worried if you check your little baggies or you check your screw count and you have a total of 8 screws left. That's normal. Like I said, each screw came with 8, so 2, 4, 6, 8, and that'll be this here. So like I said, you're gonna have a total of 8 screws left over for the motors. Save them. You never know. If you're flying, I don't know, maybe one does happen to vibrate off. If you didn't lose Loctite, you can sure use that. So this is pretty much how the unit looks. You can see the wire feeds right in through the top, and then on the bottom we have here all the nice mesh. You can see how, as it's looking a lot more complete, you can see how nice that mesh looks. It just really goes the extra mile. So what we're going to do now is introduce the PDB board. We're going to show you guys how we're going to wire that up, how we're going to mate the 2 plates together, and then we're going to move on to the flight controller and hopefully wrap this video up for you guys.